Hello class. Today we're going to be talking about scatter plots. Now this is going to be the first of a three-part series where in this particular video we're just talking about what a scatter plot can tell you, okay, and what kind of relationships you can find. In the next video we'll look at how to construct a scatter plot, and then in the third video we'll look at how to construct what we call a trend line, okay, or a line of best fit. So in this video we're just talking about observed data to address questions of association, such as linear, nonlinear, and no association whatsoever between something called bivariant data. In other words, two types of data. Okay, so let's look at what a scatter plot looks like. Okay, so a scatter plot is nothing but, okay, it is a graph that uses points to display the relationship between two different sets of data. So this is our definition right here. All right, and what we're looking at is relationships between data. Is there a connection between them? So here's kind of an example scatter plot where we just have a bunch of dots all over the place. And in this particular graph, we're trying to determine are ages of trees and diameters of trees, do they have a connection? So in other words, as the tree gets older, does it have a greater diameter? So when we look at this data right here, we've got several different things. So my question is, what does this red point here represent? Well, it represents a tree that is 25 years old and it is 8 inches in diameter. So each one of these dots represents an individual tree. So it says up here, each point can be represented by an ordered pair. So each one of these dots is a tree that we've collected data on. So like this one right here is a tree that's 50 years old, and it's approximately about 5.5 inches in diameter. Whereas this tree is 50 years old, but it is 11 inches in diameter. So it's data that we're looking at, but we do see a general trend in our data. As the tree gets older, it seems to be larger. Okay? And that's what we're looking for when we deal with scatter plots. Is there a relationship? Okay, so let's look at another one. Let's see if you can answer some questions. It says the scatter plot shows the ages and sleep times of several people. Use this scatter plot to classify each statement as true or false. So the first question is, 2 people slept for 7 hours. So we come over here and we look age and sleep time. Here's our sleep time. Here is our age. So we're looking at 2 people slept for 7 hours. So I'm not going to look on this one. I'm going to look up here to 7. And I'm going to run across, see, are there 2 people sleeping for 7 hours? And yes, there is. So this one is true. Okay, 5 people over the age of 12 were in the group. Well, we look here at 12. We come up here and we see that it runs right through this line. Well, there's only 4 people that are over the age of 12 and 1 that is 12. So are 5 people over the age of 12? No, this would be a false statement. And then last but not least, everyone in the group slept for at least 6 hours. So we have this 6-hour line right here. Is everybody above it? Yes, so everybody is true. So that's how we interpret some of this data. Now there are 4 things that I need you to really know about scatter plots. 1, raw data isn't perfect. Okay, so that's what we're collecting whenever we create a scatter plot, is we collect some raw data. Okay, and we also need to know that scatter plots are used to analyze raw data. In other words, we look at the data and we try to look at trends. And like on this last one, we were talking about sleep patterns. On this one, we were talking about diameters of trees and their age. So we're looking for patterns. We're looking for trends so that we then can predict what's going to happen in the future. We also need to know that we never connect the dots in a scatter plot. Now I know all through elementary school, we've been doing dot-to-dot puzzles and we've been having you connect the dots. Well, now that we're doing scatter plots, we're going to tell you don't connect the dots. And then number 4, this is our big one. We're looking at this word, correlation. Correlation is a word that's used to describe how the data is clustered or how it's connected. Okay, clustered means how closely the 2 quantities are related. Okay, so we're looking at how closely 2 things can be tied together. Is there a relationship or not? And we have 3 types of relationships. We have a positive correlation, we have a negative correlation, and we have no correlation whatsoever. Okay, so what does that mean? Well, let's take a look at positive correlation. Positive correlation is a graph that's going uphill. It says positive correlation is as one set of data increases, the other set tends to increase as well. That's a positive correlation. So positive correlation, we can think of it as something that we already know as slope. Positive slope is going uphill, positive correlation is going uphill. You'll notice that we also have a strong correlation here. All these dots are here kind of clustered together, forming a line. These are a little bit more spread out, but yet they're still going in the upward direction, which is a weak correlation. Then we've got negative correlation, which is just the opposite. As one set of values increases, the other tends to decrease. Okay, so a weak correlation is like a negative correlation is like a negative slope. It's going downhill. And again, we have weak and strong correlations. And then we have no correlation, where the dots are just all over the place. So there's not really any rhyme or reason to how we put the dots up there. And it shows that there's no relationship between the two types of data that we have. Okay, so what I'd like for us to do is I want us to look at some examples, and I want you to tell me, is it a positive correlation, a negative correlation, or no correlation? Pause the video and write your answers on your paper. Okay, so let's find out how you did. Okay, number one, you'll notice we have dots just kind of all over the place. This would be no correlation. Number two, we kind of have a general trend going downhill, so that would be a negative correlation. Okay, this one gives a general trend going uphill, so that's going to be a positive correlation. Okay, number four, we have a real tight grouping going uphill, so that would be a positive correlation. Number five, we have a tight grouping going downhill, so that would be a negative correlation. You'll notice how 2 and 3, they're kind of more spread out, so they would be weaker correlations than 4 and 5. And then number 6, oh my goodness, boy, I really want to connect those dots. But remember, we're not supposed to. So this one would be no correlation. Okay. Now we also have some phrases sometimes that we have to actually look at. So not only do they ask you, is the graph going to be a positive or negative correlation? They may give it to you in a statement. So here are some statements that we can look at to try to determine, is it a positive or a negative correlation? So let's look at the first one together. It says the number of hours a person has driven and the number of miles driven. Okay, so as time increases, do the number of miles increase as well? Yes, so this one as this one increases, so does this one. So this is a positive correlation. So pause the video and read the rest of these and try to determine, is it going to be a positive, negative, or no correlation at all? Okay, let's find out how you did. Number 9, the number of siblings a student has and the grade they have in math class. No correlation whatsoever. Okay. Number 10, the age of a car and the value of the car. Well, in this one right here, as the car ages, its value goes down. So as its age increases, its value decreases. So this would be a negative correlation. The number of weeks a CD has been out and the total sales. Okay, so if it's a real popular CD, kind of like the downloads that we do nowadays, this is kind of a dated question, but a CD is just music. So if it's a popular CD, as the weeks go on, okay, as the number of weeks increase, so do the total sales. So this would be a positive relationship. Now, if we talked about weekly sales, then that would be something different, but this one does talk about total sales. Number 12, the number of years a person went to school and their income. Now, typically, if you go to school for a lot of years, okay, you're in there to make a big income. So this one would be a positive. The only profession that doesn't hold true on that would be that of a teacher. We spend lots of years in school, but yet our income doesn't get higher. Okay, number 13, the number of songs downloaded on your iPod or your iPhone or whatever device you listen to and the amount of memory that's available. Well, the more songs you download, the less memory you have. So the more you have, the less memory. So this would be a negative relationship. Okay, and then number 14, the amount of time spent on the computer instant messaging or your device and the number of computers or devices in your house. Well, this one, there would be no correlation here. Okay, because it really doesn't matter how many devices you have. okay, because you're typically just doing it on one. Then number 15, the age of a house and the number of people living in the house. Again, this one would be no correlation. You can have a bunch of people living in old houses as well as new houses. So you've got to be able to do two things on the STAR test. Be able to tell when a statement has a positive or negative correlation, and be able to tell when a graph has a positive or negative correlation. And that's what scatter plots are all about. Seeing if there is a relationship between the two types of data that we're looking at. And again, there can be three types of correlations. A positive correlation, the graph going uphill, where one increases, the other increases. A negative correlation, which is going downhill, or as the X increases, the Y decreases, or no correlation whatsoever. So until next time.